Let's go ahead and take the same approach to find the inverse functions for the other trigonometric functions. Now, if I drew a horizontal line here, notice all these places where it would intersect the graph of our function. And so as it stands, cosine is not a one-to-one function, and we need to limit our graph from 0 to pi, and then if we ignore everything else, then the highlighted region between 0 and pi would be considered one-to-one. And then to get the graph of the inverse function, we can reflect it over the line y equals x here and get the graph of y equals cosine inverse of x, which is highlighted there. Okay. So the inverse cosine function is the function cosine with a little -1 in the superscript, with domain between -1 and +1, and range between 0 and pi, defined by the equation cosine inverse of x is equal to y, implies that cosine of y is equal to x. And, some instructors and textbooks will call the inverse cosine the arc cosine and denote it as ARC-COS. So similar to arc sine, arc cosine or cosine inverse has the following cancellation properties. Cosine of cosine inverse of x is equal to x if x is between -1 and +1, and then cosine inverse of cosine of x is equal to x for x values between 0 and pi. You will find this helpful when solving for angles within the functions, but also when looking at domain and range restrictions. Let's go ahead and jump into examples of evaluating some expressions. Example 2a asks us to evaluate the expression cosine inverse of -√2 divided by 2. And so this is some angle theta, and I am going to refer to a quickly drawn unit circle. And I know that there are two places between 0 and 2 pi where the x value of the terminal point would equal -√2/2. And let's come back up here really quickly. The range of our arc cosine function is between 0 and pi. And so that means that the angle that we're looking for in part A is either going to be in quadrant 1 or quadrant 2. So I can go ahead and erase this because I know that it's not going to be in quadrant 3. And the angle that gives us this terminal point is 3 pi over 4. So our final answer for this is going to be 3 pi over 4. And you could also give this answer in degrees if you would like to. And so if you gave your answer in degrees, it would be 135 degrees. So either of these would work as the final answer. Part B wants us to evaluate cosine inverse of 7/9. Remember, 7/9 represents a length or a ratio of lengths, depending on how you're thinking about it. And the output of this is going to be some angle theta that is between 0 and pi. Or if you're thinking in terms of degrees, between 0 and 180 degrees. This is another example where 7/9 is not one of our common lengths that we deal with on the unit circle. So this one is going to require a calculator. And I'm making sure I'm in degrees, and then I'm going to press second cosine to get the cosine inverse there, and then 7 divided by 9. And so that is about 38.94 degrees, which does fall between 0 and pi, so equals 38.94 degrees, and I'm going to go ahead and box that as my final answer. Part C wants us to take cosine inverse of 0, so I'll draw my unit circle, and cosine in quadrant 1 and 2 is only going to be equal to 0 at one location, and that's going to be right here because that ordered pair is 0, 1, and the x-coordinate is 0. And so what is this angle here? Well, that's pi over 2, or 90 degrees. So either of those is fine. That is our final answer for that one. All right, so part D wants us to evaluate cosine inverse of cosine of 5 pi over 4. Normally, we would cancel these out, or they would undo each other, and we'd just be left with 5 pi over 4. However, 5 pi over 4 is not in the domain of cosine inverse, so we're looking for an angle between 0 and pi, which again, 5 pi over 4 is greater than pi, so it's not in that interval. And so we need to draw our unit circle to think of where our angle is. And so our angle needs to be in either quadrant 1 or quadrant 2. 5 pi over 4 is in quadrant 3, and the cosine value is negative root 2 over 2. And so the place where it's going to have the same cosine value is in quadrant 2. If we reflect it over the x-axis, this will have the same x value there. We don't really care what the y value is. And the angle that's going to accomplish this for us is, if we reflect that over the x-axis, then this is going to be 3 pi over 4. So this is going to equal 3 pi over 4. Okay, part E says we want to evaluate cosine of cosine inverse of negative 1/2. Negative 1/2 is in the appropriate interval because up above we remember that cosine of cosine inverse of x is equal to x for x values between -1 and +1. And so this is just going to equal negative 1/2 by the cancellation property. Okay, let's look at part F, which wants us to evaluate sine inverse of cosine of 4 pi over 3. So I'm going to draw my unit circle, 4 pi over 3. So let's see, so this would be pi over 3. This would be 2 pi over 3, 3 pi over 3. And then this would be 4 pi over 3. And we need to think about what that terminal point is there. So that is going to be negative 1/2 comma negative root 3 over 2. And we are taking cosine of 4 pi over 3, which is the x value here, negative 1/2. So if we rewrote this expression, we could write this as sine inverse of negative 1/2. because we evaluated cosine of 4 pi over 3, and we found that that was -1/2. Okay, so now remember that the range for sine inverse is between -pi/2 and +pi/2. So if we are on our unit circle, we want to think about the angle between -pi/2 and +pi/2 that gives us a terminal point with -1/2 as the y-coordinate. And so here, this would be +√3/2, -1/2, and that angle that accomplishes that for us would be -30 degrees, or -pi/6. So that's going to be -pi/6 or -30 degrees. Either of those are fine. And that's our final answer for part F. I just want to quickly show you that we can check our answer. We found that cosine of 4 pi over 3 was -1/2. And so I'm making sure my calculator is in degrees, and then we could do arc sine of -1/2. And that gave us -30 degrees, which we did find was our answer if we're talking about degrees, and then radians was -pi/6. So it looks like we're good to go there. Part G asks us to find cosine of sine inverse of -1/2. And we actually just, if you look back at the unit circle that we found there, we actually found sine inverse of -1/2. And so this ends up being cosine of -30 degrees. And so if you go back over here, cosine, if this is -30 degrees, then cosine is just going to be whatever the x value is there. And that is -√3/2. So the final answer to part G is going to be positive √3/2. So that is our final answer for part G.